Why would you need a break?
Okay.
True?
Yeah.
True. I need a break, but it's okay. I'll continue. Right, next lesson now. Dropbox, DIFC, workbooks, physics, mechanics. Okay. It's not too difficult, this lesson, I don't think. Not as difficult as weight or projectiles. Alright, if you can write this down now. Did you have maths today?
Yeah.
And chemistry?
Yeah.
No EAB?
No.
That's why you had a 2-hour break.
I think like 2 hour break.
Yeah.
Really?
Yeah.
I won't just finish soon and we finish at 3. I even don't want lunch break, you know what I mean? We start at 9, but on Friday I start at 12. But I still finish at 10 to 5. I don't like this because it's Friday. You know? I prefer you just let me get a
What
break.
class have you got on Friday that has you here until 5 o'clock?
Math.
You have maths on Friday?
I think chemistry or math.
Ah, that's terrible. Terrible. Okay, let's continue.
Terrible.
Yeah. Terrible.
Maths.
Would you like maths? I know.
Maths.
It's really simple.
Yeah.
Hey,
To begin with, what were you doing today?
No, compare
roots.
chemistry and physical is simple English.
What's simple English? The maths?
No question. Yeah.
Maths is simple English. It's maths.
Chemistry is more difficult.
Chemistry's English is difficult. Yeah. Okay. So, do you remember Newton's second law? What was Newton's second law?
F equals ma.
That's it. F equals ma. There's actually another way to state Newton's second law. You can state it like this. F equals delta P over delta T. Now we'll explain what this means. So delta P means the change in momentum and delta T is the time. So you might say, well, what's momentum? Well, momentum, the P, is mass multiplied by velocity, mv. With the units, of course, being kilogram meters per second.
Is P?
P, yeah.
Is mv.
P equals mv.
Oh. I mean, it's m. Oh, it's not the same.
Ah?
I mean, it's rho.
No, it's not rho. No.
Okay.
Okay, got that?
Yeah.
Yeah. Do you know this word, momentum?
Yeah, but it's not so important in our exams.
Really?
Yeah. Maybe teacher will spend half class
On momentum.
Yeah.
Do you use the same letter P?
No.
What letter? Not P?
Maybe I forget.
Okay.
Yeah, maybe also.
You have this, Ben? So look,
What?
why do we need two formulas? Why do we need to use this formula and this formula? Like what's the difference? The reason is it's very convenient to use the other formula when the time is small. So, the reason we use this formula is usually because this is so small. Maximum 1 second. between 0 and 1 second. This is when this formula is useful. Okay, so it's a small time. In fact, the delta p is actually important. It has a special name. It's called the impulse. It's called the change in momentum. That is the delta p. So impulse is delta p. And by the way, delta p is the p at the end minus the p at the start. Yeah? Which is going to be mv minus mu. Yeah? So we call this impulse. It's the change in momentum. Okay? So you need to know this word, impulse. Change of momentum.
It says the same word as the person, describe a person who are impulse.
Give me an example.
Like he's so angry, so we can say he's really impulse person. Or
Impulsive is the word, yeah. It is the same word. Different meaning, but it's the same word. Impulsive, yeah. It's interesting that you say that, because the impulse is important, because impulse is what makes something painful. So for example, if you crash your car, the reason it's painful is because your momentum changes a lot. Okay? So at the beginning, you're in your car, the M is big, the V is big. So the momentum is big. And then the momentum is 0. So that means the change is very big. This is what's painful. Impulse is what hurts. You know, if you have a nail and you hit a hammer on it, okay, the M is big, you know, it's a big hammer. The V is big. This is at rest. So what's its momentum? It's 0, right? Momentum is 0. And then you hit it into the table. Its momentum is not 0. It's now very big because it goes very fast. So it hurts, you know. So impulse is what makes something painful, is how I think about it.
Shooting.
Like shooting, yeah. Yeah. Yeah, like shooting, yeah. The impulse, the change is great. Yeah. Now, here's a small question I want you to practice. A car is travelling at this speed and then it's brought to rest, maybe because it hit something. I want to know what is the impulse on the car. Okay, so what's the formula? The formula is, well, there it is there. So let's calculate it. It's 1200 minus 1200 20. Yeah?
Yeah.
So that's minus 24000 kilogram meters per second. And the reason for the minus is because the car was moving and now stopped.
Yeah.
So the impulse is backwards. Okay? So you can see that's a big number. That means it's very serious. You know? So that's a small example. I think you should write this down as an example. I think it's a simple little example. So here's the car. It's 1200. It's going 20 meters per second, and then maybe it hits something. So now it's going 0. Okay? Now this gives you a reason. If you had a choice, so here's a car, it's going 1200, let's say it's going 10 meters per second. And here's you. And then you can have someone on a bicycle, maybe they're going 20 meters per second, and we'll say it's 100 kilograms. Okay? Which would you prefer to hit you? The car. Why?
The speed is more.
Yeah, but I prefer the bicycle because it's not the speed that hurts you, but the momentum. So here the momentum is 12000 kilogram meters per second, and here the momentum is 2000 kilogram meters per second. So you can see there's a difference of 6. Although the speed is only half, the momentum is 6 times bigger. That means it will do 6 times more damage, even though its speed is half. Yeah? You see, because I remember on the news there was a story of a lady who was hit by, one of these big trucks. They're called HGVs. And she was crossing the road and the truck was reversing. Now, the speed of the truck was very slow. I think it was 2 kilometers per hour, reversing slowly. And it hit her. But she died because the momentum is actually quite big. If this is like 10 cars, then it's the same as being hit by one car going 20 kilometers per hour. It's the same momentum. Now, in fact, I don't even think it's 10 cars. It's probably more like 20 cars. So that means it's like being hit by one car going 40 kilometers per hour. Do you understand what I'm saying? Like, it's the momentum that matters, not the speed or the mass.
Maybe the car don't know.
Well, yes, yeah. Well, here. Well, this was an accident. This one was an accident, anyways. Okay, we'll continue.
Momentum is a kind of force.
It's like force. It's not quite force, but it's like force. We can say the change in momentum is a force. Because remember, Newton said F is the change in momentum divided by time. So it's not quite a force, but it's like a force. If the momentum change is bigger, then the force is bigger. Yeah. Right, here's a question I want you to try. You have a 100-gram nail and you have a hammer, and the hammer hits the nail with 50 newtons. And this makes the nail move with 4 meters per second. My question is, what is the time the hammer was in contact with the nail? What is the delta T? Okay? So I need you to use this formula to get the time. See if you can try it.
Delta T is 0.008.
Pretty small.
Really small.
That could be right. Let's calculate.
Yeah, this one.
It's right.
And the same answer.
Maybe you're both wrong. But probably not. So you used the formula and you got 0.008. So that's 8 milliseconds.
Yeah.
Yep, good job. Okay. Right. Here's another one to try, and then we have to go on to something harder. So here you have a football, and the player kicks the ball and the ball moves with a speed of 10. So the ball, he hits it and it moves for 10. What's the impulse? So I think you can do that quickly.
Two.
2.5 kilogram meters per second, yeah. And then the last part is, if the delta t is 100 milliseconds, what was the force he kicked the ball with? So that will be 25?
0.01?
0.1.
0.1, yeah, 25.
25 newtons. Is that okay, Ben, in somewhere?
The first one is
2.5.
just MA.
No, the first one is MV minus MU.
MV minus MU.
Yeah.
Oh, just the P.
Just the
The
delta P.
Delta P.
Yeah.
Oh,
The part B is the F.
yeah. Oh, just this F equals delta P
Over delta T.
T.
Yeah.
Second question is
Delta P over delta T.
Yeah.
And the delta P we said is 2.5 and the delta T is 0.1.
Yeah.
So it's 25. Yeah? You look confused.
why T delta T is
Oh, it's right there.
oh,
100 milliseconds.
oh.
Maybe
Yeah,
it's
we
10
Minus 3.
okay.
Is it? Ben?
Yeah.
Summer?
The first one is minus 2.5.
No, plus 2.5.
Plus 2.
Yeah, because he kicks the ball.
Oh. So
The U is 0.
the U is 0, the V is
10, yeah. Okay, continue. Yeah?
The second answer is
25.
okay.
Are you sure it's okay? The two of you seem very
Yeah,
confused.
I know.
Do you?
Yeah.
Okay, I trust you.
Yeah, I eat too much.
To be
salt.
honest,
So
He is honest. You ate too much.
yeah, so I'm tired.
Ah, Summer.
Yeah.
What did you have for lunch?
hot pot.
Hot pot.
Yeah.
How come he's not tired?
I don't know why.
in the morning I bought a macchiato.
Ah, this gives you energy.
Yeah.
What did you have this morning? I see. This is the problem. You're sleepy. You want to eat some food and sleep.
Yeah.
Okay. Try not to. Right. The biggest advantage to using the formula delta P over delta T is that it allows you to calculate the force provided by rockets. So you can actually calculate the force here using this formula. I'll explain now. There's a lot here, but I think it'll be easier with a picture. So let me draw a little picture here. Here's our rocket. And inside we have our gas. And then what happens is some gas comes firing out the bottom. Okay. So before the gas came out, it was at rest when it was in here. And then we'll call this gas here, we say mass M. And we'll say its speed is V. So now at the beginning the momentum was 0. And here the momentum is mv. So there was a change in the momentum. The momentum change was mv minus 0. So that's mv. Now usually for these questions you look at it per second. So normally you look at 1 second. So delta t is 1. So if you divide this by delta t and delta t, here you get f. But delta t is 1. So it's still just mv. Now, Newton's third law says for every action there's a reaction. So that means the force here is the same as the force here.
Yeah.
So in other words, you can say that the force is the mass of the gas per second multiplied by its speed. So how much gas comes out in 1 second multiplied by its speed? Yeah, this is kind of like a delta M, isn't it? A small mass. That gives you the force of the up force on the rocket, the thrust. Yeah? So it's a very simple formula. You just need to know how much gas per second and its speed, and you multiply it and you have the force here. That's all. Yeah? And it works for everything. Gas, water, whatever. You know, so for example, if you're standing here and you have a hose and you know the water comes out, and what happens? You feel the force this way. How much force? Well, you need to know how much water comes out per second, and you multiply it by its speed. And this gives you the force backwards. You've seen this before, haven't you? Like in the shower, if you take the shower down and you turn the water on, then it moves.
I've seen
Yeah.
before, but I don't like this. And I think it's difficult for me.
Ah, but this is an easy formula, right?
The
Right.
blocking again.
Yeah, you're blocking again, yeah. So look, you could just, I don't know what you want to write down. I'll draw a picture again. So what I'll say is, we'll say M is the gas ejected per second. Okay, and the V is the speed of the gas. So here the force T is just mv. That's not so bad, is it, Ben?
Why not?
I think you should write this down, yeah.
So,
That's my rocket.
so if the glass done, we should minus the glass. And
What do you mean?
I mean, glass has
An M.
yeah,
Yeah. But it's not, this M is how much gas per second.
just beginning.
No, well,
So
it's usually constant. Like for example, maybe you have 1,000 kilograms,
I
but
mean,
each second 2 kilograms come out.
I just I mean, shall we think about the gas and of the quality?
The
Mass,
qua-
mass. Gas mass.
You only care about the mass of the gas that comes out every second.
Okay,
You know what I mean?
I know.
So like, if 2 comes out, or if 20 comes out, 20 is better because you get more force, more thrust, yeah. Which is what you want. You understand? Yeah. What's also important about the gas is how much you can put inside. You know, how much you can squeeze inside. So I think what happens is they use like liquid oxygen, do they? Something like this. And then what happens is here it's a liquid, and then they turn it into a gas, and then they shoot the gas out.
Yeah.
No.
No?
Why?
I think this is it, isn't it?
Yeah.
So it's first the liquid, and then they turn the liquid into a gas, and then the gas is heated, and then the gas comes out the bottom.
Yeah.
Oh, you means you means you have oxygen.
Yeah, I think they use oxygen, and
maybe it's other one's technology.
actually, I tell you what they use. I have it here.
I don't know.
They use something called a special fuel called RP1LOX. I don't know what that is. It's a special fuel. Maybe it's a mixture of oxygen and I don't know what else. Okay.
Nobody cares.
Yeah, it's not too important. So look, here's an example, okay? You have a large rocket and the gas that comes out at a speed of 4462 meters per second. And this much gas comes out every second. So how much force do you have? Well, it's just this number
And
multiply this number.
Yeah.
That's all. So what is that, girl? What's that one?
Three, 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 8, 0, 7.
Yeah, so a lot of force going up.
Yeah.
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 The reason is because this is fast and this is a lot.
Yeah.
This is like 7,000 liters. It's a lot. Per second. Yeah. Okay. Let's continue. So I just have one more example to do. It's an interesting example.
It's a windy
Yeah.
day.
It's a windy day and a physics student was walking home.
No, physics students, my physics
Yes.
students.
The student stops for a moment to calculate the force from the wind.
Nobody will do this.
Ah, yes.
Yeah.
The wind was blowing at 12 meters per second into the student. The student is 1.6 meters tall and 40 centimeters wide. Okay, so look,
14.
wide, we'll say. So, here's the student. There they are. That's the student. Roughly. They're 1.6 tall and 0.4 wide. Okay, and they have a wind blowing here, and the wind is blowing at 12 meters per second.
What is the
We are imagining the student is a rectangle to make it easier.
right time?
Rectangle.
Why?
Why is easier?
Yeah.
You want to make him a circle, a rectangle, a rectangle. We'll just make him one rectangle. It's easier.
But what is a wire?
This,
Oh, yeah,
Wire,
yeah, yeah, yeah,
long
yeah,
wire.
yeah, yeah. Okay.
yeah. It's okay?
Yeah, it's okay. It's okay.
Okay. Now look, because we know the speed of the wind, we can calculate the force. What we do is we look at 1 second. Okay? So when the wind hits him, we only need to look at 12 meters. So we imagine what happens is all the air here in 1 second hits him. Because that is what happens. All the air in this box in 1 second hits him. Okay? So let's calculate how much air that is. So you know that density is mass over volume.
Yeah.
So that means mass is density by volume. And I made this easier. The density of air is about 1 kilogram per meter cube, roughly. So then that means that mass equals volume here, because that's 1. So that's equal to 12 multiply 1.6 multiply 0.4. So what's that in kilograms? Huh?
7.68.
7.68 kilograms. Now, can you see that this is the same problem as the rocket? No, it doesn't look like it. But think about it like this. Here's the rocket, here's the gas comes out and the rocket goes forward. Okay? Imagine there you have a box and the gas hits into the box.
Yeah.
Yeah?
The last thing came out.
No, like instead, I guess it's the opposite picture. Instead of the gas coming out, you have it the other way. You push the gas in. So what happens? Imagine, like you had a box and you have a hairdryer and you put the hairdryer in front of the box. What will happen to the box? Which way will it move? It'll move, won't it? So you have a force here.
Yeah.
And it's the same situation. The reason, why do you have a force here? Because you have a change in the mass. The only difference is here it comes out and here it goes in.
Yeah.
But it's the same. It's the same idea.
The mass is changing.
Yeah, okay, so it's not 100% the same. But the idea is this. If you're going to be picky with me, okay, that's fair. The mass, what's happening is you have the air is moving, and then it hits him and the air stops. So if I stand here, the air hits me, it stops. I make it stop. So what happened? The momentum, it changed.
Okay.
You have momentum,
Yeah.
now no momentum. So what did Newton say? Newton said F equals delta P over delta T. But if delta T is 1, then you get F equals delta P. So when all this air stops because it hits me, it makes me feel a force.
Okay.
Yeah? Because of Newton's third law. My body stops the air. But Newton's third law says that means I also feel a force backwards. Yeah? How much force equal to this? Okay? So you have F equals delta P, which equals mv minus mu. The v is 0. So it's just minus mu. And you know the m. And you also know the u.
Yeah.
So it's minus 7.68 times 12.
92.16.
Minus 92 newtons is what I feel backwards. Because my body pushed 92 newtons onto the air. So 92 newtons is, it's not small.
But-
Yeah.
But if you, or the force that's
You feel 92 newtons.
is minus?
Well, yeah, because if I stand here and there's a wind blowing to me, it pushes me backwards.
So, but the result was minus, so the force will be the opposite, I think.
This F here is minus.
So,
Because I feel minus. Like I'm standing here and the wind pushes me.
okay.
This
so
is plus and this is minus, so it's minus because it's pushing me backwards. Yeah. Now I don't fall because then I push forward. So I have to push forward with at least 92. Yeah. Do you understand? Yeah. I've seen this question in the exam before. Yeah. Now, yeah, well, maybe, I don't think it was a physics student. I think it was, I don't know, something else. Chemistry student, maybe, yeah. Now look, wait, what could this person do to make this smaller? Can this person change this? No. To change this? No.
No.
But what they could do, by making yourself smaller,
Yeah.
you can make this area smaller. Because remember, this area was in here.
Yeah.
And this made the M.
Yeah.
So if you made yourself smaller, you could make this number smaller. If you halved your height, then what would happen to this M? You would only have half of it.
Yeah.
So this would be half. And if you spread out your arms,
bigger.
it'd be bigger.
But he can walk to
Yeah.
shorten the 12 meter.
Ah, yeah. Yes, that's true. Actually, the walk-in wood is what is in the homework. I have the same problem in question. Where's it gone? In number 3. And in number 3, I make the man walk with a
Okay.
speed of 1 meter per second.
But actually, when the windy come to us, if we walk, we feel warmer.
Correct, correct. So in the homework question, if he walks at 1 meter per second, does this go up or down? It's bigger force.
Yeah.
Because
He had his speed.
he's increased his speed. So that means you have to look at 13 meters. Because it's the 12 from the wind. But if you walk 1 meter per second, you get an extra meter of air.
Yeah. The wind is everywhere.
The wind is everywhere.
Okay.
You get 12 meters from the wind, but if you are also walking, you are making more, covering more air.
Yeah.
So, you're right. So then that also means, what about if you walk backwards? Would that make this bigger or smaller?
I thought if we walk like this, and the 12 will be the 11. But actually, the windy note is from this place. Is everywhere. So.
It's 12 meters in front of you, moving with you. Yeah. So you can't make it 11 by moving. Unless there was a wall here or something, I don't know. Okay, so that's in the homework one. And that wasn't an exam question. So, I think what I'll do is because I think that was the only example I wanted to do. Yeah. So for tomorrow, can you try your best? Tomorrow's Wednesday, isn't it?
Yeah, Wednesday.
So what you could do, you could leave this one for next Monday, because there's a lot here. So for tomorrow, Newton's 3 laws and the projectiles, if you can try and finish those for tomorrow. And then next week what we can do this in a tutorial, and then I think the next lesson is too easy. So won't be a problem then, okay? So for tomorrow, projectiles and Newton's 3 laws. Try to have that finished, okay? Now you can go home and sleep.